Hello, Senior Stoner fans. It's the real Senior Stoner back at you for your Sicko brands, Adam, Diamond Dab of the Day. Hello, everybody. Thanks for joining me. If you enjoyed today's video, you know what to do. Join the family, send a like, and I respond to the comments. Let's grow that Senior Stoner family. Let's get started with today's topic. How does the nervous system detect and interpret pain? Wouldn't you like to know? This is a mystery that's plagued everybody in pain for 100 years. How does your brain know when you feel pain? How does it know the difference between a soft touch of a feather and a needle stick? And how does that information get to your body so your body can respond? How does acute pain come to be chronic pain? There are not simple answers to this, but we can explain and talk about it. The nervous system is made up of two main parts: the brain and the spinal cord, which combine to form the central nervous system. And the sensory and the motor nerves form the peripheral nervous system. The names make it easy to picture. The brain and spinal cord are the hubs, while the sensory and motor nerves stretch out to provide all access to the body. Put simply, the sensory nerves and impulses are about what's happening in our environment to the brain via the spinal cord. The brain sends information then back to the motor nerves, which help us to perform actions. It's like having a very complicated inbox and outbox for everything. Let's say you step on a rock. How does the sensory nerve in the peripheral nervous system know that it's different from something like a soft toy? Different sensory nerve fibers respond to different things differently and produce different chemical responses, which determines how the sensations are interpreted. Some nerves send signals associated with light touch, while others respond to the deep pressure. Special pain receptors, called nociceptors, activate whenever there's been an injury, or even a potential injury, such as breaking the skin or causing a large indentation. Even if the rock doesn't break your skin, the tissues in that foot become compressed enough to cause the nociceptors to fire off a response. Now, an impulse is heading towards the nerve in your spinal cord and eventually will make it up to your brain, and it happens like that. Your spinal cord is a complex array of bundles of nerves, transmitting all kinds of signals to and from the brain at any given time. It's a lot like a freeway for sensor and motor impulses. But your spinal cord does a lot more than act as a message center. It can make some basic decisions on its own. These decisions are called reflexes. So an area of the spinal cord called the dorsal horn acts as the information hub, simultaneously directing the brain and back down to the spinal cord to the area of the injury. The brain doesn't have to tell your foot to move away from the rock because the dorsal horn has already sent that message. If your brain is the body's CEO, then the spinal cord is middle management. They're the ones that get it done. And the brain interprets pain very well. The pain signals continue to the brain because the pain involves more than a simple stimulus and response. Simply taking your foot off the rock doesn't solve all the problems. No matter how mild the damage, the tissues in your foot still need to be healed. In addition, your brain needs to make sense of what happened. So, pain actually gets cataloged in your brain's library, and emotions now become associated with stepping on that rock. When the pain signal reaches the brain, it goes to the thalamus, which directs it to a few different areas for interpretation. It's like having it brought down from the senior office down to the people who do the analytical stuff. A few areas in the cortex figure out where the pain is coming from and compare it to other kinds of pain, which the brain is familiar with. Was it sharp? Did it hurt more than stepping on a tack? Have you ever stepped on a rock before? And if so, was it better or worse? Signals are also sent from the thalamus to the limbic system, which is the emotional center of our brain. Some pain even makes you cry. The limbic system decides. Feelings are associated with every sensation we encounter, and each feeling generates a response. Our heart rate may increase. We may even break into a sweat, all because of a rock under your foot. While it seems simple, the process of detecting pain is complicated by the fact that it's not a one-way system. That's right. It isn't even a two-way system. Pain is more than just cause and effect. It's affected by everything else that's going on in the nervous system. Your mood, your past experiences, your expectations, all how it's interpreted. And is that confusing? Pretty confusing, right? If you step on that rock after you had a fight with your wife or your husband, your response would be different than if you had it after you won the lottery. Your feelings about the experience would be tainted. If the last time you stepped on a rock, your foot became infected. If you stepped on a rock once before and nothing terrible happened to you, you may recover more quickly. You can see how the different emotions and histories can determine our response to pain. In fact, there's a strong link between depression, as we know, and chronic pain. And when does acute pain become chronic, as a matter of fact? After your foot heals, the pain sensation should stop because the nerve receptors no longer detect tissue damage or potential injury. That is called acute pain. And acute pain does not persist after the initial injury is healed. But sometimes, however, those pain receptors continue to fire, and it can be caused by a disease or condition that continually causes damage. Arthritis. People who have these horrible diseases that feel constant physical pain under their skin, it burns. So the joint is also in disrepair, causing further brain signals to the brain with very little downtime. Even in the absence of tissue damage, those neuroreceptors continue to fire. You see, there may no longer be physical cause of pain, but the pain response is your same from your brain. So it makes chronic pain very difficult to pin down, and it makes it extremely difficult to treat. The brain's a funny thing. We're all going to interpret things differently. If we were all burned by the same amount of degrees in the same spot on our hand, let's say, 5 people would all have different responses to it. Some would run to the hospital, some would put it under cold water, some might not even feel it. Let's have our dab and get started for the day here. And I want to thank you all for joining me here today to discuss how the nervous system interprets pain. I think it's important for us to know, especially people like me who are in terrible chronic pain every day, unfortunately. This has been The Real Senior Stoner. As always, if you enjoyed this video, you know what to do. Get me up to 20,000 subscribers. That'll be a big thing for everybody. The family will be expanding. Send a like, and I respond to all the comments. Have a great day, everybody, and thanks again for joining me. Hope you now will have a better idea of what the nervous system does with pain. Cheers.